Welcome back to AI.Code.Cast, everyone. So today, we're taking a deep dive into a coding problem that, well, it pops up a lot in tech interviews.
Yeah, especially at places like Facebook.
Okay, so it sounds simple at first. You need to add two numbers.
But here's the twist. Those numbers, they're not given to you as, nice, neat integers.
They're strings.
Strings. And you can't just use some built-in function to, convert them to integers and add them up. We're going to have to think a little differently about this.
So let's break it down. We're given two strings. Each of them represents a non-negative integer. The goal is to add those strings together, and then, of course, return the sum, as you guessed it, another string.
Right, so think about it. We can't rely on those shortcuts, converting to integers and back. This forces us to think about how addition actually works at its core.
It's like we're back in elementary school, adding those long numbers, column by column.
With all those carryovers.
Exactly. And, this goes beyond just, interview questions. Imagine you're dealing with sensitive data, like credit card numbers or encryption keys.
Where security best practices, they might demand that you handle those numbers as strings.
Right. This is where understanding how to manipulate strings like this becomes a real-world skill.
And don't forget about fields like cryptography or scientific computing.
Oh, yeah. Those massive numbers.
Huge. Hundreds or even thousands of digits, standard integer types. They just won't cut it.
Okay, so let's look at some examples from the problem statement. So 11 plus 123, that should give us 134.
And 456 plus 77 should result in 533.
Now, I know what some of you might be thinking. Can't we just convert them to numbers, add them, and convert the sum back to a string?
Well, yeah, you could. But think about those massive numbers we mentioned earlier with hundreds or even thousands of digits. You're going to hit that dreaded integer overflow limit in most programming languages.
So it's not just about the size of the number. It's the potential for them to be truly massive.
Right. So brute force, not going to work here.
So what's the alternative?
Well, remember what we were talking about earlier?
Back to elementary school.
Exactly. That's where this digit-by-digit addition approach comes in.
We break it down. Smaller steps.
Manageable steps. We start from the rightmost digits of both strings.
So those are in the ones place.
Exactly. Add those digits together.
Right.
Simple enough, right?
Right. But what if the sum is, greater than 9? That's where the carryover comes in.
Yep. So if the sum is greater than 9, we're going to do a couple of things. First, calculate the digit for the current position. That's basically the remainder when the sum is divided by 10.
Okay.
And then determine the new carry, which is, the result of integer division of the sum by 10.
Okay. So we figure out the digit for that position and the carryover. And then what?
We move one position to the left and repeat. We keep adding the corresponding digits, along with any carryover from the previous step. We do that until we hit those leftmost digits.
Okay, got it. But how do we actually build that final sum string?
Good question. So we're constructing our sum from right to left, digit by digit. And then once we've gone through all the digits, we need to reverse the result to get it in the right order.
Right. It's like we're writing it backwards.
Exactly.
Okay, that makes sense. Let's try walking through one of the examples. How about 456 plus 77?
Perfect. Let's start with the rightmost digits, 6 and 7. We add those and we get 13.
Okay, so the digit for that position would be 3, and we carry over a 1.
Right. Next position, we have 5 and 7 plus our carryover of 1, which totals 13 again. Another 3 for this position and another 1 to carry over.
And lastly, we have a 4 from the first string. And we don't have a digit in the second string, but we do have that carryover of 1. 4 plus 1 gives us 5.
There you go. We processed all the digits, and our result is 335. But remember, backwards.
Right. So we reverse it, and bam, we get 533. See, not as intimidating as it seemed at first, right?
No, not at all. It's all about understanding the logic, breaking it down into those steps.
So this digit-by-digit approach, it's pretty solid for handling massive numbers. But I feel like there might be even, cleverer solutions out there.
Oh, absolutely. The source material actually mentions some other interesting approaches. One of them uses a very specific feature in Python,
Okay.
and the other one dives into the world of recursion.
Ooh, recursion. Interesting. Let's take a quick break, and then we'll come back and talk about those other solutions.
All right, so welcome back. Before we jump into those other solutions, I think it's worth talking about why that brute force approach, just directly converting those strings to integers, why that doesn't work.
Yeah.
Especially for those really big numbers.
Yeah, you mentioned something called integer overflow. What exactly happens there? I mean, what's going on under the hood?
Okay, so imagine you've got a box, right?
Mhm.
And that box can only hold a certain number of things. If you try and cram more things in than it can handle, well, some of those things are going to spill out. You're going to have a mess.
So in this case, that box represents the data type that we're using to store the integer, right? And then the items are the actual numbers.
Right. And every programming language, they've got these different data types for integers. And each data type, well, it's got a limit. It's got a maximum size of the number that it can hold. So when you try and go beyond that limit, when you exceed that capacity, that's when you get that overflow.
So it's not like we can just find a bigger box. Like, what about using a long integer type?
Yeah, you could try that. But even those have their limits. And when we're talking about these numbers that could be like, longer than a Tolstoy novel, even the largest integer types, they're not going to be enough. And that's why we need these other approaches, like the digit-by-digit addition we talked about,
Yeah.
or some of the solutions that we're going to look at now.
Okay, that makes sense. So let's talk about those solutions. You mentioned one that was specific to Python.
Yeah. So Python, it has this really cool feature called Big Int. And Big Int, it lets you work with integers that can be, well, pretty much any size you need.
So no more overflow.
No more overflow. You can work with those astronomical numbers. Imagine like calculating the distances between galaxies. Numbers with hundreds of digits. No problem.
So instead of going, digit by digit,
Mm.
we could just use this big int to handle all the heavy lifting.
Pretty much, yeah. Python's got this like secret weapon for handling those massive numbers.
Can you give us a little taste of what that might look like in code?
Yeah, sure. So let's say you have those two strings, right?
Yeah.
Representing those huge galactic distances. All you got to do is you wrap each of those strings in the big int function. So it'd be like big int and then in parentheses, some really long string of digits.
And but Python just handles the addition. That's pretty magical.
Yeah, it's pretty slick. Behind the scenes, Python's doing all the work with its big int implementation, but for you, it's super simple.
Okay, so let's walk through how that would work in practice. We've got our two input strings. What do we do?
So first, you take those input strings, we'll call them like num1 and num2, right? And you convert them to big objects using that big int function. Then you just add them together, just like you would add any numbers in Python.
And that'll give us the sum as another big int object.
Exactly. But remember, we want the final answer as a string.
Right.
So then you just convert that big int sum back to a string, use Python's built-in stri function. Done.
Wow. That is super concise. So just a few lines of code to handle those huge numbers? Big Int seems like a pretty useful tool for any Python developer.
Yeah, absolutely. It's a testament to the power of, leveraging those built-in language features. It keeps your code clean, efficient, easy to read.
But you did mention that this is specific to Python, right? So what about folks working with, other languages like C++, Dev? Do they have to just stick to the digit-by-digit method?
Not necessarily. There's another really elegant solution. It works great in languages like C++ LAC. It involves recursion.
Recursion. Okay, I'm listening. How would we use recursion for this?
All right, so recursion is basically we're taking that problem of adding these two strings
Yeah.
and we break it down into smaller, like self-similar subproblems. Instead of working with the whole strings all at once, we focus on individual digits.
It's like we're breaking down the problem into smaller chunks.
Exactly. Yeah, and we keep breaking those chunks down until we get to the smallest pieces. Pieces we know how to handle. And then we combine all those little solutions to solve the big problem.
I see the pattern here, but I'm not sure I understand how to apply that to this string addition.
Okay, so imagine we've got this function. We'll call it like add strings recursively, right? It takes our two strings as input, num1 and num2. And it also takes a couple of indices, like index 1 and index 2. Those are going to keep track of where we are in each string. And we also need a carry variable to, keep track of any carryovers.
Right, okay, so those indices are like our pointers. They're telling us where we are in each string. And the carry starts at 0, right? Because we don't have a carryover initially.
You got it. Now think about our base case. What's like the simplest scenario? The point where we stop breaking the problem down any further.
I guess it would be when we've gone through all the digits in both strings. So when both of those indices are less than 0.
Exactly. So if both indices are less than 0 and there's no carry left over, we just return an empty string. If there's a carry, we just return 1. That's our stopping point.
Okay, that makes sense. What if we're not at the base case, though? What do we do with the digits?
Okay, so we extract the digits from, num1 and num2 at the current indices. But here's a little trick. If an index is less than 0, meaning we've gone past the beginning of the string, we treat that digit as 0.
Okay, so we grab those digits, and if we're out of bounds, we treat it as a 0. Then what?
We add those two digits together along with the carry, and that gives us our, sum for this position.
And then we got to figure out what digit we add to our result and the
Yeah.
new carry, just like we did with the digit-by-digit approach.
Yes. Exactly. So the remainder, when the sum is divided by 10, that's the digit for our result string. And the result of dividing the sum by 10, that's our new carry.
Okay, so we've got the digit, we've got the carry. Now what?
Now, this is the recursive part. We call that add strings recursively function again.
Okay.
But this time, we move both of those indices one position to the left. We're shifting to that next column of digits. And of course, we pass along that new carry value.
So we're just repeating the process, but with the next set of digits and whatever carryover we have. And this keeps happening until we hit that base case where both indices are less than 0.
You got it. Each recursive call gives us back a piece of that final sum. But remember, we're building it from right to left.
So just like before, we end up with that result in reverse order. We got to flip it around.
Yep, we reverse that string, and there we have it, the sum of our original two strings, calculated using recursion.
That is really cool. Recursion is a pretty powerful concept.
It is, isn't it? You break down such a complex problem into these smaller, repeating steps.
All right, listeners, we've explored a couple of really neat alternatives to that brute force approach. We saw how Python's Big Int can handle those huge numbers, and we saw how recursion can, break down this problem into manageable pieces. We'll be back in a bit to wrap things up and leave you with some final thoughts. Welcome back to AI.Code.Cast. We've been digging deep into this coding problem, adding two numbers that are given to us as strings. And it's amazing how a problem that sounds so simple, it can actually lead to some pretty interesting solutions, right?
Yeah, for sure. And it really just goes to show you that, in coding, it's not always about just finding a solution. It's about finding the right solution. And to do that, you need to really understand the problem, the limitations, and the tools that you have available.
Absolutely. So we saw how that brute force approach, where you just convert the strings directly to integers, it just doesn't work when you have these massive numbers.
Yeah.
You run into that integer overflow issue. But then we talked about some pretty elegant solutions, like using Python's Big Int and, of course, recursion.
Right. And each of those solutions, they kind of have their own pros and cons, Big Int in Python, that's super concise, it's efficient. It really takes advantage of Python's built-in features to handle numbers of any size.
Yeah, it's like Python has this, superpower for dealing with those huge numbers, especially when you're working in fields like cryptography or scientific computing.
Exactly. But then the recursive C++ solution, that one's a little more complex. But it really highlights the power of breaking down a problem into these smaller self-similar chunks, It's all about thinking algorithmically.
Yeah. Recursion, I'll admit, it can be a bit mind-bending at first, but it's pretty impressive how it, solves this problem so neatly.
It's definitely a good tool to have in your toolbox, that's for sure. And what's cool is even though we've been focused on adding strings, a lot of these principles like manipulating digits, handling carryovers, and using recursion, they can apply to, all sorts of coding problems.
That's a good point. So as we wrap up this deep dive, what are some key takeaways for our listeners? What should they keep in mind if they're tackling similar problems?
Well, first things first, understand the problem, right? Understand the constraints. Don't just jump into coding before you've considered potential issues like overflow. And then, explore different approaches. Don't just settle for the first solution you think of. There might be a better one out there.
Right. It's like choosing the right tool for the job.
Yeah.
Sometimes a built-in feature like Big Int is perfect, and other times you might need a more algorithmic solution like recursion.
Yeah, exactly. And remember, coding isn't always about finding the right answer. It's more about developing your problem-solving skills, being able to analyze and adapt and, think outside the box.
Yeah, I think this problem's a great example of that. It really pushed us to think creatively, to explore different ways to achieve the same goal.
Absolutely. And as you continue on your coding journey, don't forget about the AI.Code.Cast community, Share your challenges, your insights, your cool solutions on the forum. We can all learn from each other.
Absolutely. Thanks for joining us on this deep dive into the world of String Addition. Until next time, happy coding, everyone.